Calculating net force is easy. What is important on the test, you'll probably use it 7 or 8 times inside of problems. It means the total of all forces, and you'll have either horizontal forces or vertical. You won't have both. So it's the total in whatever direction your forces are in. Your example is horizontal, correct? We have two forces. 40 minus 10 is 30 newtons, and of course it's to the east. Let's look at all the possibilities here on these next slides. Well, you can have one force. Here's a 30 newton force to the east, and the total of all forces is 30, correct? And it's to the east. So in this case, net force is kind of trivial. It's just equal to that one force, isn't it? But net force is 30, the total of all forces. Here's another example similar, except that it's in the opposite direction. One force, all the forces added together are 60, and this time to the west. This one here has two forces, though. Now, usually what will happen here is one of the forces will, quote-unquote, win. And now, doesn't the 70 win over the 20? It does. So the direction is going to be west, isn't it? And since they're in opposite directions, you're going to subtract because that 20 cancels out part of that 70, doesn't it? So you go 70 minus 20 is 50, and of course this guy wins, is 50 newtons west. So similar with the opposite direction, here the 100 wins, 100 minus 30 is 70, and of course this guy wins, is to the east. When you're in opposite directions, you subtract. This is different though, isn't it? Aren't these two forces in the same direction? Sure they are. So you'll add them together, won't you? And obviously the direction is going to be west here because they're both going to the west. 60 and 60 plus is 120. The net force here is 120 newtons west. Interesting here, don't these two cancel totally? They're in opposite directions and they're both 50. So 50 minus 50 is 0. So our net force is 0, and of course there's no need for a direction because there is no force, just 50 newtons. Just a couple more. I got one north-south one here. That'll be a south force, that'll be a north force, but they're also equal, aren't they? So they'll cancel out to 0 newtons. Usually it's east-west, but you can have north-south, right? And it's no different. And the last one is this one. What's the net force there? Are there any forces at all? No, none. So again, this is a 0 newtons net force. Those are pretty much all the directions, all the, examples you'll have. We have this concept of balanced and unbalanced forces. Balance means that the forces cancel out to 0, don't they? So all these here are unbalanced except that one is balanced, that one is balanced, that one is balanced. And if I said all the rest are balanced a minute ago, I meant to say all these are unbalanced, aren't they? Because they're not 0. So if they cancel to 0, or if there isn't any force at all, then we have balanced force. Otherwise, if they don't cancel to 0, then we have unbalanced forces. One last thing to say is if you have a problem involving force and you have more than one, then you should add them together, or what you need to do to get net force, and use net force in the problem. Here's an example. Jan pushes east on a 1,000 kilogram car. 1,000 kilograms is down here with a force of 150. There it is there, pushing east. I'll say F1 is 150. And then D pulls east in the same car with 120. There it is, pulling still the same direction though, isn't it? So we're going to add them together. We get 270. We'll use our net force in this problem, not just one of them. So down we want acceleration, don't we? So we'll use that formula for acceleration. Here it is, and of course it's 270 now over 1,000, and we get an acceleration of 0.27 meters per second squared. All right, that's it for net force, and here is your video code. Bye.